To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all the GCE O-Level Paper 2 Part B. Now in the previous chapters we discussed the Part A, that is the structured essay type questions. Now these are known as essay type questions. Now here, as you already know, there are 5 questions. But starting from question number 5, because already the first 4 questions were structured questions. So starting from question number 5, 5, 6, 7, 8, 9 are essay type questions in Part B. Out of those, you need to answer only 3 questions, and also you have to write the answers in the booklet provided to you, not on the paper. That you have to remember. So answer only 3 questions from the questions number 5, 6, 7, 8 and 9. And you need to write the answers in the booklet provided. You know the instructions. There are instructions given in the booklet as well. You have to read that and answer it properly. Is that okay, students? So then, here also you have to remember there will be different parts. Some of the questions have 3 parts, A, B and C. Some will have part A and B. And usually the 5th question is a biology related question. So 5th question, A part, given below is a sketch of a part of the human digestive system. So if you look at the diagram, you can see now this part is the esophagus coming and joining with the stomach. Then here you can see this part, the C-shaped structure is the duodenum of the small intestine, and here you see is part of the large intestine, and this is what is labeled as R. You can see is a leaf-like structure, so you all know it is the pancreas. And here this particular structure and secreting organ of the digestive system is the liver. You all know liver normally secretes bile, and bile is stored inside the gallbladder. This small sac-like structure is the gallbladder. So the bile, the secretion from the pancreas, pancreatic juice, both of them open into this duodenum, the C-shaped part of the beginning part of the small intestine. So this is part of the digestive system. So you can see Q is the liver, P is the stomach and R is the pancreas. Now pancreas you all know acts as the endocrine gland as well as it produces enzymes. So in the digestive system it produces the pancreatic juice that contains the enzymes. So that is here. At the same time, in the pancreas there are the islets of Langerhans. There are the alpha and beta cells. Beta cells produce insulin and alpha cells produce glucagon. Both of those are hormones. They are involved in regulating the blood glucose level. Now in addition to that, you all know students, stomach, there are the muscles. There is the lining of stomach that is covered by the mucus layer, so that the enzymes do not react with the proteins of the stomach wall. And inside the stomach, there is hydrochloric acid. And also with the movement of the muscles of the stomach, there is mechanical digestion. Now normally from the mouth cavity, the food that is coming here is known as the bolus. And thereafter with mixing of the gastric juice, we call it the chyme. And the chyme again undergoes mechanical digestion. There the food particles are broken down further into very tiny particles. And there is hydrochloric acid to provide the acidic medium. And there is pepsin, renin and hydrochloric acid in gastric juice. Pepsin converts protein to polypeptides and renin is there to coagulate milk, and hydrochloric acid to provide the acidic medium. Thereafter, the chyme moves into the small intestine where secretion from the liver, that is bile, secretion from the pancreas, pancreatic juice, and the intestinal juice, all of them mix with food and the digestion completes there. So finally in the small intestine, all the digestive end products are formed. You all know all those processes. So with that introduction, students, I'll move on to the next slide. So here, again the diagram is given to you so that it's easy for you all to answer the question. Given below is a sketch of a part of the human digestive system. And on this side, the first question, name the parts labeled P, Q and R. So here of course I have the space to write the answers. You will be writing it in the booklet. So P, as we identified it, it is the stomach. Then Q, we have identified it as the liver. And R is the pancreas. So you can see P stomach, Q liver and R pancreas. Is that okay, student? So then I'll move on to the next one. The second part, again I have put the diagram and the introduction in most of the slides, so it's easy for us to answer the question. Then the second one. Describe briefly how food is subjected to mechanical digestion in P. I mentioned that to you all, due to the movement of the stomach wall, the muscles of the stomach wall, there is mechanical digestion. So you all know when we say digestion, that is the breaking down of food into simple organic components that can be absorbed by the body. That is the digestive system. So initially the food is complex organic compounds that are broken down into simple components that can be absorbed. That is the process of digestion. In addition to that, the digestive tract absorbs the minerals that have been digested end products, and also removal of undigested materials. All that happens in the digestive system. And when we take digestion, there are two types. One is chemical digestion, the other one is mechanical digestion. Chemical digestion is where the enzymes act on the substrates and convert them to the digestive end products. But when we say mechanical digestion, mainly it starts in the mouth cavity or the buccal cavity, where the food is broken down into pieces with the help of the teeth. And also it is mixed with saliva, so it becomes the bolus. But inside the stomach also, there are muscles arranged in such a way that the muscle, the wall of the stomach can contract, it can press the food and it can break it into further smaller pieces. That is what happens when you don't chew your food properly. Now, even though sometimes when you are in a hurry, you don't chew the food properly, then you tend to swallow the food as larger particles. So, those particles go into the stomach, but they need to be broken down. Then only the food can enter into the small intestines. So, for that to happen, there is mechanical digestion inside the stomach. That happens due to the movement of muscles of the stomach wall. And that is also peristaltic movement. The name given to the movement of the stomach wall is also known as peristaltic movement. Now, you all know through esophagus also, food moves due to peristalsis. Similarly, in the stomach also there is peristaltic movement. So, if we write the answer here. So, here we can write there is mechanical digestion due to the movement of the stomach muscles, or you can say peristaltic movement of the stomach muscles, or you can say due to the movement of the wall of stomach. So you can write one of these answers. There is mechanical digestion due to the movement of the stomach muscles, or peristaltic movement of the stomach muscles, or you can say due to the movement of the wall of the stomach. So if you write one of those, that is more than enough. That is how mechanical digestion occurs in the stomach. Is that clear, students? So then we'll move on to the next one. Now again here we have the diagram. The third one, a secretion essential for the emulsification of lipids contained in food is produced by Q. Name that secretion. Now in this we have already identified Q as liver. I told you all liver produces bile. Bile is temporarily stored in this small structure, that is the gallbladder. You all know this. Now here this is the gallbladder where the bile is stored. So L is the liver, and in the gallbladder. And when there is digestion from the gallbladder, bile is given out and it opens into this duodenum. That is the C-shaped beginning part of the small intestine. And this bile is needed for emulsification of fat. What is emulsification? Now, if you take fat, when it is there as a large structure, a large molecule, you all know fat is also a large structure, then the surface area is less for the enzymes to act on it. But when bile is added to this, bile and fat, what happens is they are broken down into tiny droplets like that. This process is what we call as emulsification. Now, when they are there as tiny droplets like that, there is more surface area. So, the lipase enzyme can easily digest the fat, the lipid, into fatty acid and glycerol. Is that okay, students? So, that is the process of emulsification. So, here, secretion essential for the emulsification of lipids contained in food is produced by Q. Name that secretion, it is bile. So, this is the answer you need to write, but here I have explained what emulsification is. So, then I'll move on to the next one. Fourth question, A part. What is the enzyme which is secreted by R and contributes to digest lipid? Now, in the diagram, in the previous one, we identified R as the pancreas. So, pancreas produces pancreatic juice. Now, pancreatic juice contains the enzyme lipase. So, the enzyme lipase converts lipids to fatty acid and glycerol. So, that is how they contribute in this digestion. Here you can see. Fourth one, A part, what is the enzyme which is secreted by R and contributes to digest lipids? It is lipase or lipase. You can call it as lipase or lipase, L-I-P-A-S-E. Then B, state the two products formed by the action of that enzyme on lipids. So, you all know when lipase acts on lipids, you get fatty acid and glycerols. Fatty acid, and glycerol. So, those are the two structural components of lipids. You are familiar with that. So, those are the end products of lipid digestion. So, then part 5. The pair of hormones, insulin and glucagon produced by R contributes to regulate the internal environment of the body. So already I mentioned this to you all. Pancreas acts as an endocrine gland as well. So that is R is pancreas, insulin and glucagon. So A part, what is the factor that is regulated in the internal environment of the body by the action of those hormones? So insulin, when there is more glucose in the blood. When the glucose level is higher, you all know normally the normal glucose level in a healthy person should be between 80 and 120 milligram per 100 milliliters of blood. So if it is more than that, after digestion of food, there is higher amount of glucose in blood, so that has to be reduced. To do that, what happens is insulin converts the glucose into glycogen or fat in the liver. So there, what is the factor that is regulated in the internal environment of the body by the action of those hormones? So I said about insulin. Glucagon, on the other hand, when the amount of glucose in blood is less than the normal value, there glucagon converts the fat or the glycogen into glucose. So both of them involve in regulating the level of blood glucose. So here they have asked for the factor. So if we write it as level of blood glucose, that is 5. Glucose. Because here the regulation is already mentioned. So we don't have to write that. Level of blood glucose. Then B part. Explain briefly how those hormones contribute to regulate the factor you stated in A above. So level of blood glucose. How they regulate it. So to explain that, we can say when the level of glucose increases in blood, insulin converts glucose to glycogen or fat in the liver. So although the hormones are secreted by pancreas, these changes occur in the liver, that you all know. At the same time, when the level of glucose is less than the normal level, glucagon converts glycogen or fat to glucose in the liver. So that is how they regulate the blood glucose level. So here you have to explain briefly how the hormones contribute to regulate the factor you stated in A above. So insulin helps to decrease the glucose level when it is more than the normal amount. Glucagon helps to increase the blood glucose level if it goes down below the normal level. You have to write both. You have to specify the hormone and the change that is happening. Is that clear, students? So with that, we'll move on to the next one. Part B. Kidneys are considered the main organs which perform nitrogenous excretion in humans. So now, before this, we did the question that was related to digestion, the digestive system. There you all know the food undergoes digestion, the nutrients are absorbed, the undigested food that is removed from the body in the form of feces. But feces is not an excretory material. Why? Because feces is not produced within the body during a metabolic activity. So, when we say excretion, removing excretory materials that are produced within the body during metabolic activities. For example, the carbon dioxide. Or when amino acid is broken down, ammonia is produced and that is converted to urea or uric acid. Then creatinine, these are all excretory materials. Then the salts, the additional water that is produced, all these. So, sweat, urine and the exhaled air, they are excretory materials. And the process by which these are excreted is what we call as excretion. And out of those, urea and uric acid are the main nitrogenous waste material. And the organ that produces this nitrogenous waste material is the kidney. Kidney produces urine that contains urea and uric acid. So, here that is what is mentioned to us. Kidneys are considered the main organs which perform nitrogenous excretion in humans. So, the first question, what is excretion? Already I explained that to you all. If we are to answer that question, removal of excretory materials produced in the body during metabolic activities is known as excretion. So, that is how excretory materials are removed. So, that process is known as excretion. Is that okay? Then the second part of the question, name a nitrogenous excretory product removed by kidneys. So, I told you all there are three products. The main ones are urea and uric acid. In addition to that, in urine, there is a small amount of creatinine as well. So, you can write any one of the three. I'll write all three. Urea, uric acid and creatinine. So, you can write any one of the three answers. So, when you are writing this also, students, I have mentioned removal of excretory materials. You can also say it as removal of waste products. Now, that is another term that you can use here. You can use it as instead of excretory materials, you can say waste products. And also you have to say they are produced in the body during metabolic activities. So, when you write the answer, the two components that have to be included in this are one thing, you have to either say waste products or excretory materials, and also you have to say they are produced during metabolism. That is important for this first part of the answer. Then this of course are the nitrogenous excretory products. I have written all three. If you write one of those, that is more than enough. Is that clear, students? So, with that, I'll move on to the next question. The third one. What is the structural and functional unit of kidneys? Now, you all know the kidney is made up of two parts, the cortex and the medulla, and in that there are the nephrons. Nephrons are the structural and functional unit of kidneys. Nephron. Nephrons, you can remember, you have the arteriole supplying blood, then you have the glomerulus, afferent arteriole, then the efferent arteriole. In between you have the network of capillaries, that is the glomerulus. With that, the Bowman's capsule, then the ascending limb, then you have the Henle's loop, descending limb, then the convoluted, proximal and distal convoluted tubules, and the collecting ducts. All together is a nephron. So that is the structural and functional unit of kidneys. And within that, the production of urine occurs, and that also happens in 3 stages. The ultrafiltration, selective reabsorption, and also the secretion in 3 steps. I'm sure you all can remember that. So the nephrons are the structural and functional unit of the kidneys. Is that okay, student? So then, if we move on to the next question, 4th part. One step in the process of forming urine in the structural and functional unit of the kidneys is known as secretion. So, one step is secretion. A part, describe briefly how secretion occurs. And B part, state the other 2 steps in the formation of urine. So, here already I mentioned to you all, initially it is the ultrafiltration. So, the blood is supplied through the afferent arteriole into the glomerulus. You all know afferent arteriole has a bigger diameter, efferent arteriole has a smaller diameter. Because of that, there is high pressure inside the glomerulus. Blood is flowing under high pressure. Due to that, components from blood is filtered through the Bowman's capsule as Bowman's filtrate. But blood cells and blood proteins, plasma proteins do not get filtered. But all the other components get filtered, and when they are passing through the arms, the descending arm and the ascending arm as well as the Henle's loop, there is selective reabsorption. Many of the components are reabsorbed, and thereafter there is secretion of substances. So when this secretion occurs, ions like hydrogen ions H+, potassium ions K+, ammonium ions NH4+, then there is vitamin B, creatinine, and some of the drugs. They come from the blood capillaries. There is a network of blood capillaries around the tubules of the nephrons, and from those blood capillaries, these substances are secreted into the tubules of the nephron. So that process is what we call as secretion. So if you are to describe secretion, you have to say entering of H+, K+, NH4+, then creatinine or creatinine, then vitamin B and drugs from the blood capillaries into the tubules of nephron is known as secretion. So that is what we call as secretion. Then the B part, state the other 2 steps in the formation of urine. So they are, of course, I have already mentioned to you all, ultrafiltration and selective reabsorption. Or you can also write it as selective absorption. selective reabsorption or selective absorption. So these are the two steps, ultrafiltration and selective reabsorption. So like I told you all, this is the first question. So if you have chosen this question, you have to answer all parts, and when answering, students, you have to make sure you need to write the question number 5, and in all the pages that you use to answer this question, you have to write the question number as 5, and you have to make sure you write all the numbers of the parts very correctly. If it's part A, first question, A part, B part, C part, like that, you have to number all the answers correctly. So that is very important. Let's say if you didn't know the answer to this A part, so you have to write for A, leave enough space to answer that question, and then you can write the answer for the B part. If you can't remember the answer, then leave that space. Then you move on to the next question, and finally when you are checking your paper, come back and answer this question. So here also you can't leave out any of the parts, because all 20 marks is divided among all the parts. So you have to answer all the parts of these particular questions. Is that clear, students? So with that, I'll move on to the next question. So this is question number 6. Now, as you see the diagram, you all can see, students, this is something related to chemistry. You can identify this diagram as the fractional distillation column. So there, you all know this is related to that particular concept. So if we look at the question number 6, A part, a longitudinal section of a fractionating tower. So in the industry, we use the fractionating tower. In the lab, we use the fractionating column. So a longitudinal section of a fractionating tower used for refining crude oil is given below. So you all know what crude oil is. Petroleum crude oil, that is obtained as a natural resource which contains a mixture of hydrocarbons. That is why we use the method of fractional distillation to separate the different components. Contained in abundance are the compound X in the fraction released from the outlet 1. So if you look at the diagram here, the different outlets are numbered 1, 2, 3, 4, 5, 6, 7. And you all know here the crude oil is passed from this side, and then here there is the boiler where the boiling point, there is heat generated, heat is provided to the crude oil, and it gets converted to vapor, and the vapor moves through this particular fractionating tower. And because these are like chambers and the vapor has to move in a particular zigzag pattern, what happens is as it goes up from bottom to top, when the vapor moves, the temperature decreases. So what happens is the component with the lowest boiling point will go up to the top and will be released from the upper outlet, whereas the components that have high boiling points, they will come out through these particular outlets. You all know that. So based on that, as you go from bottom to top, the temperature decreases. So the components with higher boiling point come out from the bottom outlets, whereas the lowest boiling point comes out from the first outlet. So here what they have said is contained in abundance are the compound X in the fraction released from the outlet 1. So compound X in outlet 1. Compound Y in the fraction released from the outlet 4. So compound Y is from outlet 4 and the compound Z in the fraction released from the outlet 6. So compound Z is from outlet 6. I'm sure you all can understand that. So based on this only we need to answer the questions. Is that clear, students? So you all know when we say petroleum crude oil, it is a mixture of hydrocarbons. You all know what hydrocarbons are. They are compounds made up of carbon and hydrogens only, carbon and hydrogen. So they are usually alkanes. Starting from one carbon, that is methane, CH4, it goes up to many number of carbons. And each fraction comes out from different outlets, and you have discussed the uses of these fractions as well. You are familiar with them, the fuels, petrol, diesel, kerosene, LP gas, then tar or bitumen, then there is the different substances used for different purposes. So they are all obtained by fractional distillation of petroleum crude oil. So with that, we'll move on to the question. Here again the question is given to you on this side so that it is easy for us to answer the questions. So we can look at the fractionating tower. Now look at the first question. By what common name is the group of organic compounds contained in abundance in crude oil known? So like I said, they are hydrocarbons or alkanes. You can write any one of the names. So I'll write both here, hydrocarbons, or you can say alkanes. You don't have to write both. Here students, I am writing all the possible answers. Like I did before also, I am writing all the possible answers. You need to just write one answer, hydrocarbons or alkanes. With that, the next part. Again, the question is given on this side, so I am not going to read it again and again. The second part, name the crude oil refining technique employed in the tower. So like I told you all, fractional distillation. You all know the meaning of distillation. You have a mixture that has components, either varying boiling points or components with volatile components, which have to be extracted without their properties being damaged. Then what we do is we provide heat. By providing heat, we convert the components from the liquid state to the gaseous state or vapor state first, and then we condense it. That process is what we call as distillation. And in that there are three types: the simple distillation, fractional distillation and steam distillation. Here we look at fractional distillation. In fractional distillation, there are similar components in the mixture. So here they are all hydrocarbons or alkanes with significant difference in their boiling points, so that they vaporize and condense at different temperatures and they can be separated easily. So here the technique that we employ is fractional distillation. Fractional distillation. Fractional distillation. I'm sure you can understand that. Then the next question. Part 3, the boiling points of the compounds X, Y and Z are Tx, Ty and Tz respectively. Write them in the ascending order. Ascending order is the increasing order. Now like I told you all students, here you can see as we go up this way, the components, the boiling point decreases. Boiling point decreases actually. As we go up, boiling point decreases. So component 1 will have the lowest boiling point. Tx will be the lowest boiling point. Then in between we have Ty and Tz. So you need to write it in ascending order, increasing order. So it should be Tx, Ty and Tz. Like I explained before, we get the component with the lowest boiling point, the LP gas, methane, they come out from the first one. Methane is anyway a gas, so the LP gas, usually propane and butane, it comes out from the top. Whereas here, it is the bitumen or tar that has the highest boiling point, usually comes out from the bottommost outlets. You are familiar with that. So here, if you are to arrange them in ascending order, you can write it as increasing order Tx, Ty and Tz. You can write it this way, or you can write it as Tx, Ty, Tz. That is also correct. Or else we can even write it in the other order where you use the greater than symbol. Tz is greater than Ty y that is greater than Tx. All give the same answer. So either way you have to give the idea that Tx is the smallest or lowest value of boiling point, then Ty, and the highest value is Tz. Is that clear? You can write one of the three answers, but you have to write all three. Write them in ascending order, increasing order. Is that clear, students? So with that, we'll move on to the next question. Fourth one. X is a compound with a single carbon atom and containing carbon and hydrogen only. Draw the dot and cross diagram of a molecule, X molecule. So here, X is a compound with a single carbon atom. So you all know, if it is a single carbon atom, hydrocarbon, what is it? It has to be CH4. You all know the chemical formula. Anyway, when you say single carbon, you all know it is methane. So CH4. If not, you all know the way to calculate the chemical formula of a particular hydrocarbon. What is the common formula we use? We use the formula CnH2n plus 2. So if n is 1, 1 plus 2 into 1 plus 2, so that becomes 4. Then you know it has to be CH4. So if the number of carbon changes also, you all know to calculate it. And you all know how to name them as well as to write the structural formula. But here what they have asked is, they have asked for the dot and cross diagram of methane, that is CH4. So to write the answer, what do? We need to write carbon in the middle. Usually the atom of the element that is in less numbers is written in the middle. The other atoms go around it. There are 4 hydrogens, and you all know it has to be the dot and cross diagram. So dot for electrons of one atom, cross for the electrons of the other atom. So they are dot and cross. Then dot and cross, because in all the bonds, each carbon gives 1 electron, hydrogen gives 1 electron. So he also dot and cross. So he also dot and cross. Is that okay, students? Dot cross diagram. So carbon, hydrogen, carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So there are 4 carbon, hydrogen, single covalent bonds. And for those bonds, each 1 electron is given by hydrogen and 1 electron is given by carbon. And you look at it, carbon has 8 electrons, so octet is complete. So it is a stable electronic configuration. Hydrogens each have 2 electrons. So this is the dot cross diagram of compound X with a single carbon atom containing carbon and hydrogen only. So you all know this is methane. Is that clear, students? So then with that, we'll move on to the next question. Fifth part of the question, write the balanced chemical equation relevant to the complete combustion of 1 mole of compound X in oxygen gas. So here you need to write the complete combustion of 1 mole of compound X. So already you all know it is methane. So when there is complete combustion of hydrocarbons, what are the products? Carbon is converted to carbon dioxide and hydrogen becomes H2O, water. So here of course it is CH4 molecule. You all can write the physical state. If not, without the physical state also it is fine. But you have to balance the reaction. Here of course I will write it with the physical state. CH4 is in the gaseous state, methane gas plus O2 gas. So from that you will get carbon dioxide, that also in the gaseous state, and water gas. Now we have written the reactants and the products. We need to balance the equation. Carbon, there is only 1. So it is balanced, 1 carbon dioxide. But hydrogen, there are 4 hydrogens. So to get 4 hydrogens, you need to have 2 water molecules, 2 H2O. And if you balance the oxygen, here there is O2 and there are 2 oxygen atoms. So you need 4 oxygen atoms. That means you need 2 O2 gas. So the balanced equation is CH4 gas plus 2 O2 gas giving rise to CO2 gas plus 2 H2O gas. So that is when you heat. So here if you want, you can put the heating symbol or you can write it as heat. So this is anyway complete combustion. Is that clear, students? So in this, you can leave out the physical states. Without that also, if you write the balanced equation, you will get full marks. Is that clear? So that is the answer for the 5th part of the question. With that, I'll move on to the next one. Part 6. The substance released from outlet 7 of the tower is used to construct roads. Name that substance. 7. Now I told you all the highest boiling point is bitumen or what we call as tar. That is what is used to make or construct roads. The carpeting of the roads is done using this bitumen or tar. So that is what you need to write here. So bitumen or you can write it as tar. The tar roads, carpeted roads, that is done using the substance bitumen. The component that has very high boiling point because it has higher number of carbon. It is also an alkane, a hydrocarbon with higher number of carbon. Is that clear, students? So that is the answer for the 6th question. The substance released from outlet 7 here of the tower is used to construct roads. So from that you can relate. Even if you don't remember each and every component coming out from the outlet, from the property or from the description they gave, you can easily identify. Now if it is petrol, it is the fuel for vehicles. If it is LP gas, you all know it's used for household cooking purposes. Then diesel, it is used for again fuel in different vehicles. So like that you all can relate them based on their properties. Then there is naphtha that is used to make chemical substances. Like that you all can relate it. So with that I'll move on to the next part. Here part 7. State an environmental problem caused by the gaseous components that would be released to the environment during refining of crude oil. So we already saw one gaseous component, CH4, methane. Now methane is a greenhouse gas. You can remember that methane is a greenhouse gas. In addition to that, there are other fuels. Diesel, petrol, kerosene, they are all being extracted using fractional distillation. So when they undergo combustion, now we wrote the combustion for methane also. Then also there is carbon dioxide released. So there what happens? They are greenhouse gases. These greenhouse gases cause global warming. So from this, if you come plus oxygen, you will get CO2. That is also something that can be released. And when they provide heat, now here crude oil, the heat is provided. There is combustion. So during combustion also carbon dioxide will be released. So methane, carbon dioxide, they are greenhouse gases. But you can't write the answer as greenhouse gases because here they have asked for environmental problems. Environmental problem. So the problem is global warming. So you have to write it as global warming. Global warming. Is that the only problem that can occur? No. Now from burning of these components, combustion of fuel in vehicles, emission from vehicles, when they combine with the environmental, the water molecules and all that, you get the photochemical smog. That is also a problem, an environmental problem caused by these components. So you can write that as well, photochemical smog. So emissions from vehicles combined with the components in the atmosphere, they cause this photochemical smog. Then there is another thing. Now you all know from petroleum crude oils, there is sulfur dioxide released, because sulfur is present as a component in petroleum crude oil, and when there is fractional distillation, there is sulfur dioxide being released to the environment. Now, when sulfur dioxide dissolves in rainwater, there is H2SO3, sulfurous acid being formed, or else sulfur dioxide can be converted to sulfur trioxide. So, sulfur dioxide we discussed is a primary pollutant. Sulfur trioxide is a secondary pollutant. Sulfur trioxide can dissolve in water forming sulfuric acid, H2SO4. Now, these two, sulfurous acid, sulfuric acid, they are all strong acids and they contribute to acid rain, or they cause acid rain. That is also another environmental problem that can be caused, acid rain. So, there can be global warming due to methane, or when there is fuel being combusted to provide the heat energy, carbon dioxide evolve. Those are greenhouse gases which lead to global warming. Then photochemical smog from all these emissions, and also acid rain due to sulfur dioxide. So, those are the environmental problems. You need to write only one. So, there it says state an environmental problem caused by the gaseous components that would be released to the environment during refining of crude oil. So, you don't need to write all three, you need to write only one. And remember, you need to write global warming, but you cannot write greenhouse effect. Do not write greenhouse effect, because greenhouse effect, anyway you all know, is a natural phenomenon. It is there to retain a certain amount of heat in the atmosphere, so it does not become too cold in the night. For the survival of living organisms, there should be a certain temperature maintained. But due to the accumulation of greenhouse gases as pollutants, the global warming is a problem. So, you have to keep that in mind, students. So, with that, I'll move on to the next question. So, this is part B of the same question. We have completed part A. This is part B. So, when you are answering the question, you have to answer both part A as well as part B together. Now, here, if we look at the question, A is a strong acid and B is a strong base. Two products are produced in the reaction between A and B. One of those products is sodium chloride. So, here if you are to identify them, now you can see there is A and B. A, they have said, is an acid. So, normally for acid we can write it as HA, and base we can write it as BOH. And from here, this is not the correct chemical equation. Just to get the information I am writing this. You all know one product is sodium chloride. Always when there is a reaction between an acid and a base, you get a salt and water. So, you know the other product also, water. So, this is salt and water. So, here, since you get the salt as NaCl, you all know the positive ion comes from this. So, this should be NaOH. And the negative ion, Cl, comes from the acid. So, that is the A component. So, here this has to be HCl. A is a strong acid and B is a strong base. So, we have identified the acids and bases. You all look at the salt. You all know this is a double displacement reaction where the H combines with OH. So, we get water, and B combines with A. So, B is the cation or the positive ion, sodium. So, this is sodium hydroxide, and the anion or the negative ion chloride is this component A minus. So, this is H plus and A minus, B plus and OH minus. So here this has to be HCl. So acid A has to be HCl and base B will be sodium hydroxide. Likewise, you can identify the acids and bases. And the setup is given to you. You can see here heat insulated container. So this is something like a regiform or styrofoam cup or a plastic cup, or you all know a wooden container inside which you have the copper vessel, something like that. Insulated container. Then there is the reaction mixture. Then the thermometer. Thermometer to observe the heat change. So you all know this is related to energy changes related to chemical reactions. Whether heat is released or absorbed. Energy is released or energy is absorbed. To identify that, you are familiar with endothermic and exothermic reactions. So something related to that. And also based on the observations, you can even calculate the amount of energy released or the amount of energy absorbed. You are familiar with all the concepts. So that is why there is a thermometer to read the change in temperature. Then you have a glass rod here. Why do we use a glass rod? To mix the reaction mixture so that the reactants are mixed together properly, as well as the temperature, the heat energy is distributed uniformly throughout the mixture so that you will get a proper temperature reading. The heat is distributed evenly. Mixing of reactants as well as distribution of heat evenly so that you will get the correct thermometer reading. So for that we need to have a glass rod as the mixer and thermometer to read the temperature. Then you have the reaction mixture and the heat insulated container to prevent the loss of heat to the environment. Because here we will be doing, or this activity is usually used to calculate the heat released or heat absorbed. So there you cannot lose any heat energy to the environment. At the same time, the reaction mixture should not absorb heat energy from the environment. So to prevent that, we use a heat insulated container. Now in addition to these, students, you all can remember we can also use a cover as well, a lid. That will also help to prevent heat loss. Now here usually heat is lost by conduction, that is prevented by this container. At the same time there is convection possible. That can be prevented by a lid. And to prevent radiation, normally there are vacuum flasks or vacuum containers, or else the wall of the container is made shiny so that heat loss by radiation can be prevented. So the three methods of heat transfer, the heat loss can be prevented by different methods. You are familiar with all that. Now that is related to the activity or the diagram and the introduction given. Now let's look at the questions related to this. So here again the same diagram and the introduction is given to you. First question, write the chemical formulae of the compounds A and B. So we have already identified the compounds. So we can say A, HCl. You need to write the chemical formulae. So here also it's not a must to write the physical states. You all know it is in the aqueous state, but only the chemical formulae. Say hydrogen chloride, HCl. And B is NaOH. So always when you write the answer, say which one is hydrochloric acid. A is HCl and B is NaOH. So that gives a better clear answer. That is the answer for the first one. Write the chemical formulae of the compounds A and B. A is HCl, B is NaOH. Then the next part. The second one, name the compound that is produced as the other product during the reaction between A and B. Already I wrote the equation. You all know the other compound is water. So here water. Since they have said name the compound, you can easily write it as water. Water. That is the other product. Is that clear? So then the next one, part 3. Describe briefly how the compound you stated in 2 above is formed during the reaction between A and B. I mentioned this before when I gave you the introduction, but you all can remember, students. Now when we have HCl and NaOH, now here you know the products. Now Cl and Na combine to form NaCl. At the same time, H plus ions and OH minus ions combine and form water. So here it is H plus and OH minus from the base. They combine to form H2O. That is what we call as neutralization. So this is neutralization. So this is what you need to explain. You have to say H plus ions from the strong acid or A, or you can say from the strong acid, and OH minus ions from B or from the strong base combine to form water molecule. That is the explanation you need to give. So here, describe briefly how the compound you stated in 2 above is formed during the reaction between A and B. So here we can say H plus ions from the strong acid, or you can say A, combine with OH minus ions from the strong base, that is B, to form water, that is H2O. You can write this explanation, or what you can do is you can write the equation also. So there, what are the components? Now you all know strong acid dissociates to H plus and Cl minus. The same way strong base also dissociates completely NaOH, Na plus and OH minus. So from the strong acid you have H plus and Cl minus. From strong base you have Na plus and OH minus. When that combines together, you get water, plus you do have the Cl minus and Na plus. They combine to form the salt. But you all know salt is an ionic compound, sodium chloride, that also completely ionizes in water. So here these will be present as ions itself, Cl minus. So you get H2O, Na plus and Cl minus. So you can cancel off these and you can write it as H plus plus OH minus forming H2O. So you can either write this explanation or you can write these two equations. But you have to write both of them. You have to show that Cl minus and Na plus, they do remain as ions in the solution. So H plus and OH minus combine to form water. Either explanation is fine for this question. So this is how we explain or describe briefly how the compound you stated in 2 above, that is water, is formed during the reaction between A and B. Is that clear, students? So with that, I'll move on to the next question. So then the fourth part of the question, I have put the diagram here, so that is needed for this question. Part 4, an apparatus set up to determine the heat change associated with the reaction between A and B is shown in the diagram. So this is the diagram I already explained to you all. You all can see here the heat insulated container, the reaction mixture is inside, the glass rod and the thermometer are shown to you. So you all know why we use all these components here, the materials, why they are used. Then if we look at the question for A part, in the apparatus, what measure has been taken to reduce the heat loss? So you can see they have used a heat insulated container. Heat insulated container has been used. Heat insulated container has been used. So that is what you need to write here. What measure has been taken to reduce the heat loss? And I told you all, this prevents the heat loss by conduction. The container does not conduct heat to the environment. So you can understand that. Then the B part of the question. Suggest a course of action which can be taken to reduce further the heat loss in this apparatus. Now, like I mentioned to you all students, here this prevents heat loss by conduction. But convection is where, now here see, if this mixture is hot, then the air above the mixture will absorb heat from there, and by convection, heat can be lost to the environment. To prevent that, normally what do? We put a lid here. If you can put an insulating lid. What are the materials that can be used? It can be a plastic lid, even a styrofoam or regiform lid. It can be a cardboard lid, or it can even be a thin piece of wood. Not very heavy, that is suitable for this particular container. You can even use a piece of wood, a plank of wood. There, what can you do? You can make 2 holes so that you can insert the thermometer and the glass rod in any of those. The regiform or the cardboard or the wood, you can make the holes and you can insert them through that and you can cover it so that heat loss will be prevented. Another method. Now here, by conduction, the heat loss is prevented, but if this particular insulated container is thin, then there can be some small amount of heat lost to the environment. So to further prevent that, what can we do? We can use a nested cup. That is, you can place one insulated container inside the other. So in between, this is also an insulated container. In between there is air. Now air is a poor conductor of heat. Air is a poor conductor of heat. It is a poor conductor of heat. So this further prevents heat loss by conduction. So you can have one cup within the other cup, and also you can use a lid. These are methods by which further loss of heat can be prevented. Is that clear, student? So then you can write any one of these methods. Suggest a course of action which can be taken to reduce further the heat loss in this apparatus. So you can say, place one insulated cup or vessel inside another vessel. That is one method. Another method we can write. Now here also I am writing all the possible ones. You need to write only one course of action. The other one we can say, cover the vessel with an insulator lid, like I can say wood, cardboard, or styrofoam. Styrofoam also can be written as regiform. So one of these can be used. You can either write place one insulated vessel or cup inside another vessel, or else you can write cover the vessel with an insulator lid like wood, cardboard or styrofoam. Is that clear, student? So that is the answer for these two parts of the question. Then I'll move on to the next one. Here, part 5, 50 centimeter cube each of A acid solution and B base solution of equal concentration were taken and mixed in the above apparatus. The temperature change occurred here was determined to be 10 degrees Celsius. So here they have given you the volume and the change in temperature. Now if you look at it, now if I just draw the container only here, just to get an idea, I am not drawing the full setup. Here we have 50 centimeter cube of acid plus 50 centimeter cube of base. So in total, there is 100 centimeter cube. You need to keep that in mind, 100 centimeter cube. And the change in temperature, normally when we do calculation, what we write as theta is given to us as 10 degrees Celsius. And you all know, students, normally temperature change in Celsius and Kelvin is equal, only when considering the change. So 10 degrees Celsius is the change in temperature, that is theta. Okay. So if we look at the questions related to that, here you can see what are the readings that should be taken to determine the above temperature change. What are the readings? Now you have HCl and NaOH separately, or the acid and base separately. You can measure their initial temperatures to make sure that they are in the same temperature. If not, if the temperatures are different, we normally take the average of the initial temperature of the two solutions. So one thing, we need the initial temperature of the acid, or you can say A and base, or you can say B. You can say initial temperature of the acid and base, or you can say the initial temperature of the solution A and solution B, or acid A and base B. Anything is fine, as long as you have to say that it is the initial temperature of both. So like I said, if they are both in the same temperature, room temperature, no problem, you can take that value. Otherwise, you take the average of the two temperatures. If the temperatures of acid and base are different, then you take the average as the initial temperature. Then what do you do? After you mix, you all know normally acid-base neutralization is an exothermic reaction. That means the heat energy of the acid and base are high, whereas the salt and water are less. So there is heat released to the environment. So because of that, the temperature of the solution will rise. The temperature of the reaction mixture will rise. So it is an exothermic reaction. So what will happen? When the reaction proceeds, the temperature reading, the thermometer reading will increase. It will stay at a maximum value. It will reach a maximum value when the reaction is the maximum, and thereafter, once the reaction is complete, we need to keep it for some more time. Again, it will start decreasing. But what is the temperature we consider? We consider the highest temperature reached, not the final temperature where we stop the activity. Because the final temperature, after the temperature goes to the high value, it will come down again. So we don't take that value. We take the highest temperature. So when you write also, you have to write highest temperature reached. reached or observed, or at least you have to say highest temperature. So the initial temperature of acid and base, and once the two are mixed, so here highest temperature reached by the mixture. Or you can even say reaction mixture. So after mixing, the temperature will increase. It will reach a maximum value. Again, it will start decreasing. So after it starts decreasing, only after some time we stop the activity. So we take the reading, that is the highest temperature obtained or reached by the mixture. Is that clear? Do not write as final temperature. That is incorrect. You will not get marks. Is that clear, students? So those are the two readings that you need to calculate the change in temperature. So change in temperature will be highest temperature minus the initial temperature. Is that clear? So with that, I'll move on to the next question. Part B. Calculate the heat change associated with the above reaction. The specific heat capacity of the reaction mixture is 5000 joules per kilogram per degree Celsius, and its density is 1 gram per centimeter cube. So why do we need the density? We assume that the density of the reaction mixture is the density of water 1 gram per centimeter cube, so that you can calculate the mass of the mixture, reaction mixture. Because to calculate heat, Q equals mc theta. That is the equation. So here Q is equal to mc theta. You need to find mass. To find mass is equal to density into volume. So what is the volume? We calculated it as 100 centimeter cube. Here I told you all, when you add two solutions, acid and base, 50 centimeter cube each, we get 100 centimeter cube. So here density is 1 gram per centimeter cube. The volume is 100 centimeter cubes. So the mass is 100 grams. But this also needs to be converted to kilograms. You can do that here, or you can do it with the calculation. So here I will write it with a different color. You can calculate the mass in kilograms. So that is going to be 0.1 kilogram. If not, with the calculation you have to do. So to calculate the heat, Q, that is mc theta. What is m? 0.1 kilogram. You can substitute this, or you can write it as 100 divided by 1000 here. Either way is fine. And what is specific heat capacity? C is given to you 5000 joule per kilogram per degree Celsius. So that is 5000 joule per kilogram per degrees Celsius. And the theta was given to us as 10 degrees Celsius. So then, if you calculate the value, 0.1 into 10 becomes 1. So 1 into 5000 is 5000, and the unit will be in joules. Why? The kilogram minus 1, and degree Celsius minus 1, and degree Celsius get cancelled off. So you end up with the unit joules. 5000 joules of heat will be released. So here calculate the heat change associated with the above reaction. So heat change is 5000 joules. We can say heat change equals 5000 joules. Is that clear, student? So that is how we calculate. You have to make sure that you do this conversion. You do it here and substitute, or here you substitute as 100 divided by 1000. Either way, the unit should be in kilograms. All standard units, so that you get the energy or the heat change in joules. Is that clear? So with that, I'll move on to the next part of the question. Sixth one. Sketch an energy level diagram to illustrate the energy change occurring in the chemical reaction between A and B above. So here they have put 20 marks. That shows that it is the end of the question. So this is the last part of question number 6. So sketch an energy level diagram to illustrate the energy change occurring in the chemical reaction between A and B above. So already I have explained to you all, this is an exothermic reaction. Energy is released by sodium hydroxide and HCl. They have higher heat energy compared to sodium chloride and water. So reactants have more energy, products have less energy. So heat is released. So you need to show that in the energy level diagram. So you all know how to draw the energy level diagram. We need to have the energy axis. Then we need to have the reactants and the products. So here we need to label the y-axis as energy, and the unit has to be kilojoules per mole. You have to write that as well. Then, now here you all know when the reaction proceeds, it has to go from reactants to products because energy has to be released. So here of course we can write it as reactants and products, and you show the arrow from reactants to products where you show the energy being released. You can write it this way, or else I will use a different color. You can write it as NaOH aqueous plus HCl aqueous. So either you can write it as reactants or you can write the reactants itself, NaOH aqueous and HCl aqueous. The same way, instead of writing it as products, you can say NaCl aqueous and water liquid. Now here students, when it comes to energy level diagrams, you all can remember the physical states are very important. Because if you use NaOH aqueous and HCl aqueous, the heat change is a particular value. If you used sodium hydroxide pellets in the solid state, then of course the heat change will be different. What is the reason? Because there is a heat change associated with the dissolving of NaOH in water. So that also will release heat. Then the final heat change will be different. So because of that, you have to specify the physical states as well. So you can either write as reactants and products, but if you are writing the reactant and products, you need to write the physical states also. Here we use the solutions, water-based solutions, aqueous solutions. Is that clear, students? So this is the energy level diagram that you need to illustrate for the particular energy change occurring in the chemical reaction. And also you all know this is an exothermic reaction. So I will just mention that as well. This is an exothermic reaction. So this is the diagram that is needed for the question. This is for you all to remember. It is an exothermic reaction. So always an acid-base neutralization, which is a double displacement reaction, is an exothermic reaction. It is an example of an exothermic reaction. You can remember that. So with that, students, I have completed the 6th question also. So in this chapter, we discussed the first 2 questions of part B. Therefore, there you saw the 5th question was a biology question. All the questions were related to different biology units. Now, this 6th question is a chemistry-based question related to chemistry lessons. So like that, you will have different questions starting from question number 5 to question number 9. So according to the instructions given to you, you all know you need to answer 3 questions. And when we say 3 questions, you have to answer all the parts of a particular question. Now here question number 6, starting from fractional distillation up to this part, you have to answer all the parts. The total marks will be 20. So then only if you leave out any parts, you will be losing marks. So you have to make sure that you answer all the parts of a particular question. So with that, students, I am going to end this chapter, and in the next chapter, I will discuss the rest of the questions with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.